So this section is about physical and chemical changes and physical and chemical properties. When we talk about a physical change, we are talking about something that only changes the appearance or maybe the physical state of the object, but it doesn't change what it is. It doesn't change the composition. So if we were able to look in at the atoms and molecules, they would not be changing. The molecules would be the same. So here's an example. This is a state change, water boiling. So in liquid water, the little water molecules are like this, and they're very close together. When it goes into the gas state, the molecules are still the same. It's still the same substance. All that's changed is that they're further apart from each other. So that's a physical change as opposed to a chemical change where the identity of the substance does change. So this is an example of a chemical change. We've got atoms rearranging, and so we end up with different substances. So an iron nail rusting. So here we have the nail. Originally it's just iron atoms. And when it rusts, it combines with oxygen, and now oxygen is in here, and this is bonded together in a 2-to-3 ratio. It's a new compound. So it's not just that the molecules are separated from each other, but we didn't have molecules before, and we only had iron, and now we've got this compound, iron oxide. Yes, still not working. Another example, dry ice subliming. So dry ice doesn't melt and form a liquid. That's why they call it dry ice as opposed to regular ice, which I guess would be wet ice, right? Because it gets everything wet. So you got the carbon dioxide molecules, and they're frozen. When they go into the gas state, just like with the water, they just separate. Nothing changes. They're still carbon dioxide. So that's a physical change. Here's another example of a physical change. So if we take some sugar and dissolve it in a cup of water, sugar is composed of individual molecules that look like this, and they're all really nice and close together in the little crystals. When we put them in the water, what happens is that the molecules are the same, but now they separate from each other and they swim around in the water. But the molecules themselves are exactly the same. So the molecules haven't changed. It's a physical change. Anytime you have something just dissolving or a state change, it's going to be a physical change. This is an example of a chemical change. So a little propane burner like you might take camping. Here's the propane. The molecules look like this, have this formula. When they burn, they combine with oxygen and they form carbon dioxide and water. And so now we have different molecules. You see that? So they started out like this, and now there's different molecules. So the molecules changed. That would be a chemical change. So any questions? Chemical change versus physical change, thinking about what's happening to the particles. Are they changing into different kinds of particles, or are they just maybe separating? So those are changes, and then we also have properties that can be identified as chemical or physical. So a physical property, the substance can display that, or we can observe that property without changing the composition of the substance. So an example would be odor. So gasoline has a distinctive smell. When you smell the gasoline, it remains gasoline, right? What you're smelling is actually a few of the gasoline molecules that have gone up into the air, and they go up into your nose, and they hit little receptors there, and you smell stuff. But they are still gasoline molecules. So that's a physical property, the smell. The taste of something. Salt tastes salty, right? When we're tasting it, we're not changing its chemical composition. It's still salt. The appearance of something. A melting point, a boiling point, the density, okay? So if you take a piece of wood and measure its density and then cut it in half, the density is still the same, And we've changed its appearance, right? But we haven't changed the individual components. It's still wood. A chemical property, when you display a chemical property, the composition of the substance changes. Basically, it undergoes a chemical reaction. A chemical property is a description of a possible chemical reaction. So gasoline is flammable. If we observe that gasoline burning, just like with the propane in the previous example, it's combining with oxygen and making new molecules. Corrosiveness, acidity, toxicity, these are also examples of chemical properties. So let's see how much we understand here. We're supposed to identify each of these as being a chemical or physical change, and then identify what kind of property would be demonstrated there. So again, what we want to think about is what's happening to the molecules and the atoms. So the first one is a copper wire is hammered flat. Is that going to change the composition of the wire? No, it's just going to smush it out, right? So that would be what, chemical or physical? Physical. So that's a physical change. I'm a physical property, physical change. So I'm going to call that PC for physical change. And what kind of a property is demonstrated? The property would be copper wire can be hammered flat. Is that a chemical property or physical property? Physical property. This is kind of an odd question. This is a spoiler here. Whatever the change is, the property's the same. I'm not sure exactly why they ask it that way, but whatever. Okay, a nickel, like a 5-cent piece, right, dissolves in acid to form a blue-green solution. Chemical. That one's not as obvious. Sometimes when we have to identify these, and there will be a couple of questions on the exam, to form, it's forming something new. That's a big clue. So if that's a chemical change, is this a chemical or physical property? It's a chemical property. Dry ice sublimes without melting. That's going to be a physical change. And what kind of a property? Also a physical property. A match ignites when struck on a flint.
Chemical.
Yeah, that's going to be a chemical change. Because we are permanently changing the stuff that was there on the match head, right? We're producing new things. That's just like the gasoline or the propane burning, right? So anytime you see something burning or combusting, that's a chemical change. So then that would be also a chemical property. Okay, any questions? Sometimes these can be a little trickier than whoever is giving them to you. I guess that would be me, intends. But on an exam, I will try to be careful to pick ones that should be obvious to just regular person. I wouldn't think the nickel one is really obvious.
I apologize about my laptop. The fan is loose in there. I didn't get it.
No, that's okay. I'm fine. Okay, so the diagram on the left, that would be this one, represents liquid water molecules in a pan. And we're going to heat that up and vaporize it. And they're asking us which of these panels best depicts the water molecules after they've been vaporized. A. So when we vaporize, that's changing from a liquid into a gas. That's a state change. And all that's happening is the particles are changing their movement and spacing, right? So here we had individual water molecules. Doesn't that look like a little Mickey Mouse head, kind of? I like Mickey Mouse. And so here we still have little Mickey Mouse heads. We still have the same molecules. Any questions?